In miscellaneous treatment, we have learned regarding the softening, that is by lime soda and a zeolite process, then then estimation of hardness, then fluoridation and defluoridation we have seen by Nalgonda technique. Now, in today's class, we will be discussing regarding the reverse osmosis and nano filtration. Okay. Now, this particular reverse osmosis and nanofiltration both are having the similarities but a little bit of the changes. Now, for the reverse osmosis and the nanofiltration, why we are going to study is, if suppose if the salts are more in the particular water, right? Now we need to make it suitable according to the IS standards. So when we are having more amount of salts, right, we are going to have the problems like calcination, then your efflorescence, right? Then we are going to have when if we are going to use that particular hard water, if we are going to use, then we may have the problem of white patches may be seen on that particular water, and then boiler will be having the calcination problems. So if we want to remove those the salts and minerals, right, whatever it is there in that particular water, we will be using this particular reverse osmosis process, or we are going to use this particular nanofiltration process. This will be exclusively, it will be used to remove the higher amount of salts or the TDS level from water. So we will be seeing now what is this, the reverse osmosis. Okay, now what is reverse osmosis? Now the water which has to be treated, right, if suppose the water is going to have more amounts of salts in it, right, salts or TDS level, that is the total dissolved solids are more in that particular water, right, how we are going to remove it? We are going to remove that particular higher TDS water or higher salts and minerals. We are going to remove it by using the semi-permeable membrane. How we are going to remove it? The water will be passed with having those salts and minerals. It will be passed through the semi-permeable membrane under the pressure. Okay. Now, what will happen due to the semi-permeable membrane? These semi-permeable membrane, they are going to absorb whatever the salts are there in that particular higher amount of salts and minerals water. It is going to, those salts and minerals will be getting absorbed by the semi-permeable membrane. The semi-permeable membrane will be placed like this. Then when the semi-permeable membrane is going to be placed, the salts and minerals is going to be get absorbed by this particular semi-permeable membrane. When the salts and higher content of salts and minerals are going to be get absorbed, what is going to happen? The salts and minerals is going to be observed here, and then it is going to be this particular side water, it will be free from salts and minerals. So by this particular method, we can remove those salts and minerals whatever are going to cause the hardness, or if suppose if we have more amount of chloride, if it is having, then we can remove those chlorides, those alkalinities, those hardness of those particular water. So whatever content is higher, we can remove it by using the reverse osmosis process. Now we will see how we can remove. We will take one particular container. In that container, the semi-permeable membrane will be placed. Then the water which is going to have more amounts of salts and minerals, we are going to place it at one side, and then it is going to pass through this particular semi-permeable membrane under the pressure. Okay, under the osmotic pressure. Then it is those salts and minerals is going to be absorbed in this particular salts and mineral, this particular semi-permeable membrane, and this side particular water, what we are going to have, the water molecules. It won't be having the salts and minerals with it. Okay. Now this particular, now the very suppose this side the water is getting, the semi-permeable membrane is getting, has absorbed all the materials in it. Now there will be some amount of water, it will be remained. We are going to take this out by, we call it as a salt concentrated water. We are going to take it out. Here we are going to remain with the fresh water. Okay. Now this particular reverse osmosis process, as I have told, it operates at a particular pressure. Okay, it does not operate below 600 kg per centimeter square, and it can be operated more than 1000 kg per centimeter square. Okay, so we call it as an the low pressure reverse osmosis, and we call it as an high pressure reverse osmosis, and we can utilize this to treat water of around 1000 mg per liter to 10,000 mg per liter. Suppose these total dissolved solids, if it is in the range 1000 to 10,000 mg per liter, that particular high amount of TDS level, as I have in the IS code, right, the limit is up, the limit, it does not allows the 1000 mg per liter, so it is going to have the salts and minerals to it. So by reverse osmosis process, this high amount of TDS can also be get removed by this particular reverse osmosis process. So we can remove the TDS level up to 1000 to 10,000 mg per liter. Okay, now 1000 to 10,000 mg per liter will be operating under the low pressure conditions. Okay, it can be operated under the low pressure condition. That means as your total dissolved solid content is high, we can have it with the low pressure, and more than 10,000 mg per liter we should utilize the high pressure reverse osmosis. Okay, then this is regarding the reverse osmosis. Then we will see the regarding the nano filtration. Okay, now reverse osmosis, we have left one particular important aspect regarding the reverse osmosis. The reverse osmosis rejects the particles smaller than 0.0001 micrometer. Okay, that means the particle smaller than 0.0001 micrometer, it cannot be treated by having the reverse osmosis. Okay, now we will see nanofiltration. The nanofiltration technique is similar to your nanofiltration. The only difference is it is going to have the micropore membrane, right, of around 0.001 micrometer, and the reverse your nanofiltration, it works for a water with having the level of around 1000 to 10,000 mg per liter of the salts with it, and this particular nanofiltration will be having the same process that we are going to pass it through the semi-permeable membrane under the osmotic pressure. Okay, and it is going to reject the particles more than 0.001 micrometer, that is nothing but nanometer. It rejects, I repeat, the difference between the reverse osmosis and your nanofiltration is RO rejects the particle smaller than 0.0001 micrometer, and nanofiltration rejects the particle greater than 0.001 micrometer. This is the difference between the ultrafiltration and the nanofiltration. So here we have completed the module 4. Here we have discussed regarding, in the module 4 we have discussed regarding the disinfection methods of disinfection with the merits and demerits, chlorination, that is breakpoint chlorination, and determination of chlorine demand, estimation of a bleaching powder. Then in the miscellaneous treatment we have seen the lime soda, then we have seen the zeolite process along with what is hardness, how we have to remove the temporary hardness, all those things we have seen. Then we have seen what is fluoridation, what is defluoridation, how we can remove the fluoridation and defluoridation. We have seen Nalgonda technique, and just now we have seen the RO and the nanofiltration, along with the both what kind of a differences it is going to have with each other. So here we complete the module 4. In the next class we will be seeing the incomplete part of module 2, that we have taken some of the theoretical classes. We have had some classes, the live classes till your sampling. From sampling onwards we needed to cover the module 2, that we will be covering in the next class, along with the BIS limit, water quality parameter, then the intake structure, and all these things we will be covering in the next classes.